Look at a modern city at night, and you see a world humming with hyper-connected devices. Because this technology is so responsive, we assume the physical microchips powering our lives are inherently smart. But strip away the software, and those physical circuits are entirely blind. Hardware cannot think. The microprocessors inside our devices are simply empty shells, forged from silicon, built only to follow strict, rigid commands. For a machine to actually function, it requires two distinct inputs. First, it needs a way to mathematically interpret reality. Second, it needs a precise set of instructions telling it what to do with that interpretation. Every piece of digital technology we rely on draws its power from a silent, invisible partnership between two historical fields, algebra and algorithms. Algebra acts as the language of computation. We use it to frame mathematical mysteries and define the exact variables of our physical world, such as speed, distance, or a missing weight on a scale. But identifying an unknown variable does not solve it. For that, you need an algorithm, a strictly logical, step-by-step sequence of operations to calculate that specific unknown. Algebra is the tool we use to ask a precise question. The algorithm provides the path we walk to find the answer. We can trace the genesis of this partnership back 12 centuries to Baghdad and to a 9th century scholar named Muhammad ibn Musa Al-Khwarizmi. Before Al-Khwarizmi, equations were often treated as isolated puzzles. His first major breakthrough was introducing algebra to the world as a highly systematic method, organizing these static mysteries into a formal language. His second breakthrough was developing strictly organized step-by-step procedures to solve those algebraic equations. From these highly structured methods, the modern concept of the algorithm was born. By unifying a formal mathematical question with a logical procedure to solve it, Al-Khwarizmi provided the blueprint for modern computation, centuries before the first physical computer was ever built. When vacuum tubes and silicon transistors replaced mechanical logic, engineers needed a way to automatically apply complex mathematical formulas at scale. This transition revealed an absolute law of modern computing. Every single software program in existence is built entirely from algorithmic instructions. Yet, those instructions are useless in a vacuum. To actually perform a calculation, an algorithm must be fed algebraic expressions and specific equations. Inside a machine, the two depend entirely on one another. Without algebra, computers have nothing to calculate. Without algorithms, they have no instructions on how to perform the calculations. Consider a real-time GPS routing system on your phone. To begin mapping a route, the software uses algebra to define the core variables of your physical travel, your speed, your distance, and your available time. Algorithmic sorting trees process millions of route combinations in milliseconds to find the fastest path. This exact same duality protects global banking networks. Algebra models baseline financial behavior, while high-speed algorithms instantly spot anomalies and block fraud. The most complex, high-speed digital systems we interact with every single day are ultimately just Al-Khwarizmi's ancient dual framework, operating at the speed of light. Today, modern artificial intelligence and machine learning represent the most sophisticated application of this partnership yet. The foundation of AI relies heavily on advanced linear algebra and matrices to mathematically model relationships within massive datasets. Machine learning algorithms then execute those models. They drive the pattern recognition, calculate the predictions, and generate new images by processing those specific algebraic matrices step by step. It's a strict, inescapable dependency. Without algebra, artificial intelligence has no framework to map our world. Without algorithms, it cannot execute the models to actually think. Algebra and algorithms operate as two halves of the same mathematical brain, the dual engine converting ancient logic into the code of our digital lives.